Hello guys, in this video I would like to explain about correlation analysis in Python. Uh, you know that correlation uh, uh, assessment of some data set with another data set. I mean, suppose you have observed data, recorded data, and you want to compare another data which is synthetically generated or simulated data from some models or some experiment or from some scenarios, and you want to make a comparison between these data set. One of these statistic which you can use is the correlation coefficient. You need to calculate the correlation coefficient of each data set with the observed data and then compare all these correlation. And I will not I will not recommend to only rely on the correlation coefficient. You can calculate other statistic like root mean square error, mean absolute error, mean error, and percent bias, etc. And then you can decide about a data or a model which have better performance based on all these statistics. But correlation coefficient or correlation analysis is one of those important statistics which you can use for this purpose and maybe for other purposes as well. And maybe if you don't have more model, you have only one model, still you want to see that how much correlation or how much closely the observed data is reproduced by a particular model or experiment or scenario. So in that case, correlation is important to use. Maybe you are aware that how you can do correlation analysis in R and SPSS, Manitube, etc. And Microsoft Excel as well. But if you don't learn Python, then please watch this video until the end so that you will learn that how you can do correlation analysis in Python. These are the some graphs which show different situation about the correlation coefficient. Look at this graph, the first one. You know, the data is just very close to the line and the line is, going up. This means that uh, this is x axis and this is y axis. This means that this is the first value of, at x axis and y axis, this is the value. So at x is here and y axis here. So when you're going to the right side, when we're increasing the x, this the value on the y-axis also increase. It is now here. You can see like here. So this is higher than this, and so on. You are going to the right side on x-axis, and the values. This means that the values are increasing if you are going on the right side, and similarly, we can see that when going up, the values of the y is increasing as well. So this means that both variable are moving in the same direction, particularly in the upward direction, that if x is increasing, then y is increasing as well. And by the way, the values are very close to the line. So this means that a very strong positive correlation. Positive in a sense that if one variable is increasing, the other is increasing. This is strong positive correlation. And if one variable is decreasing, the other is decreasing, still this is strong positive correlation because both variables are moving in the same direction. Look at the second graph. You can see that the values are not very near to the line. So this means that this is a positive correlation because one variable is increasing on x-axis, the y variable is also increasing on the y-axis, but this is not a strong correlation, so you can say it's a weak positive correlation. Still it is a positive correlation, but it is weak. Look at this. You can see the line is going down, and why the line is going down? Because if we are increasing, we are moving to the right side. This means that the values of the x-axis are increasing, the values on the y-axis are decreasing is until here. You can see that the maximum value of x is this one, and this is the minimum value of y is somewhere here, and the minimum value of y is this one, and this is the maximum value of y, the minimum value of x and the maximum value of y. So this means that if we increase x, y is decreasing. So this means that the variable are moving in the opposite direction. One is increasing, the other is decreasing. So this means that, and the values are very close to the line. So this means that this is strong negative correlation. Similarly, this one, this is also, the values are not very near to the lines like this, but this is negative, so this is called negative weak, negative correlation, and these values are not very near, not very far away, so this is something like moderate negative correlation. And similarly, you can interpret moderate positive correlation if the lines, the values, the data values are a bit closer to the line as compared to this plot. And this data, you cannot see a pattern increasing or decreasing, so we can say there is no correlation, or perhaps if there is, that should be very, very weak. It looks like there is no correlation. So this is all about interpretation, because if you plot the data, you can see that how you can guess the correlation coefficient, but still you need to calculate it numerically so that you can get a solid value. So this is all about the correlation analysis, and now let's move to Python, that how you can do this in Python. We will do the simple correlation analysis today, and the next video we will do about Spearman ring correlation, and then Kendall-Tau correlation. So today we are doing this simple correlation, and this is now import met plotlib dot pyplot as PLT. So this is just to plot for plotting purpose, and then this is also some for plotting, because I'm doing a plot here like this one, scatter plot. So, and numpy is for generating this data and calculating the correlation. And remember that we are calculating this correlation is, we are calculating using numpy, and then we are using panda, and then we are using another package. So you can use any of these packages, maybe little differences, but not significant differences, you will see. So now let's import this, and then you can make this data, but I have generated this data. You can use this data as well, and of course you can use your own data which you have in your file, or you can use from online, etc. So just draw this data. This is the x np.random.normal. Just draw values from normal distribution with one mean value, one standard deviation, 1 and 100 observation. And then I just wanted to correlate this with the x-axis. I just added x and then draw this random number, 100 random number with 0 mean value and 1 standard deviation. So you have two data set now, x and y. And now I just wanted to see how the scatter plot look like, because I shown you multiple scatter plot, and you can guess about the correlation coefficient. So this is about the scatter plot. You already know that how to draw a plot, because I have done multiple videos and I explain this. So this means you just plot this. When you run this, you will plot this data. Yes, this is, and then you are just labeling x. So I just mentioned x-axis label, y-axis label, and you need to mention your x-axis label and y-axis label. This is general, it's not specific to my problem, because I have general data. And then this is the title, and then show the plot. So just run this, and you will see how this look like. Okay, just make it a little lower, and you will see, yeah, there is correlation, but it's not looking very strong. It can be a moderate, something like this. Just look at these plots, so you can guess from plots as well at how the correlation will look like. Okay, now calculate the correlation coefficient, and remember this, we are using numpy package for calculating this correlation coefficient. Correlation matrix name np.correlation coefficient and Pearson correlation matrix. Okay, so the Pearson correlation, you can plot this correlation matrix as well, but I think it's not important for us, but you can do this same way as we did this. So you can see that the correlation coefficient that's look like it is 0.75. So it's not very strong, but it is, yes, it is look like okay, but not. Look at the graph, so you can guess from the graph. So this is the final results of the correlation of this analysis. I mean, the Pearson correlation dot matrix. Okay, and the results are stored in Pearson correlation, so you can, of course, then show the value of Pearson correlation here. Now, using pandas, you can use pandas to calculate the correlation as well. Just you need to import pandas as PD, and I already the data, so I don't need this data. But this need the data frame, so you need to convert this to the data frame. But you need to combine that first like this. Just do like this. Let's try another way. X and Y. It's not working, then we will do in the other way. Okay, so now show DF. Okay, it's look like this. There are no labels on the top, but let's see how this. Okay. Okay, I think there should be a problem with this now. Yes, there is a problem. This is not working. Let's see. We can solve this problem. Okay. Okay, so let's see whether there is label on the top. No, still no. When they are converted now, let's see this. It will not work, of course. Yeah, there is no label X and Y. So I think we can do this with this data, and I will explain this in the next another video, because we need to generate, we need to show label on the top. So I will do this in another video, that how we can do this data. But if you want to do, you can generate the same, the data which is mentioned here like this. You can generate data X, so the label can say, okay, so this there will be a data that is X which have these values and Y which have these values. I think this is a good idea, because we have done one with that data, and now we can do this with this data. And of course, when you are doing this in the real life, you will have your own data, and you will not using these synthetic data sets. So let's do with this data and not with the one which we already generated. So now you can generate this data frame, but remember that this is data, so you need to write data here instead of X and Y. Okay, run this. So, okay, it's perfect. Now you need to calculate Pearson correlation dfx dot core dfy. Syntax is different, and now you can print the correlation, the values of the correlation. Remember that this is 0.99, because these values are very close. Remember, I mean that if you draw this will be very close on the line, because 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Of course, when the x is increasing, y is of course increasing. So when you drop a scatter plot, the values will be almost on the line. So this is obvious. There is no need to worry about this. And you can calculate the matrix. So you can calculate and then you can print. How will look like this? Yes, look like this. Correlation between x and y is 1. Yeah, it's 0.9999, and this of course you can round up this to 1. Okay, so this is about how you can do this in pandas. And now this is now another package, so you can do this correlation analysis in this as well, the third one. So whatever you like, you can do. And now you can use both data sets. So I will use the previous data set which we generated here. Yeah, here. So again, it's only generated, but you can generate again. And you can do this correlation with this new package, not this one. This one with this package SCIPY. Calculate the correlation coefficient, Pearson correlation, and then you can print the values. Yeah, so the value is here, the value is a bit different, but remember that I generate the values again. So when you generate the values, these are the random values. So it can make different. It can be different than the previous one. So you can see the correlation coefficient is 0.667 and the p-value is 3.536 e raised to the power minus 14. So you can see the significance as well, and you can see the correlation coefficient as well in this package. So in some way they are different. So if you are interested in the significance as well, beside the correlation coefficient, you can use this method, this package. And now again calculate the correlation coefficient here because I generated the values and the correlation is a bit different. So let's see here how this is. Yeah, here also this is okay. Again there is some error, so let's see. Yeah, it's again 0.667. So as I already mentioned that when you are generating the random numbers, it can be different. So in the previous it was 0.75 something, but with the new generated data it is 0.667, and also with the other package which we have done now with this one. So the same values 0.667 and 0.667. So this is all about correlation coefficient, that how we can calculate correlation coefficient using 3 different packages, NumPy, Pandas, and SCIPY. And if you are interested to see the significance as well, you need to use the last package, this one. And if you want to calculate only the correlation coefficient, you can use either of these, and this will give you both correlation coefficient and the significance. I mean the p-value. So I think it's better to use this one if you are interested in both, or at least it will give you the correlation coefficient. So this is all about today's video, and I hope you learned something about how we can do this correlation analysis in Python in 3 different ways. In the next video, we will do some Spearman rank correlation test and Spearman rank correlation and Kendall-Tau correlation. So thank you very much and see you in the next video. Ciao.